So welcome to CSC 243. This is our final session before we take a short pause for spring break. Can everyone see my screen?
No.
No.
Yeah.
I'm glad you said something. Can everyone see my screen?
Yeah, we can see it.
Okay. So what we have is a brief table. And I'm going to refer to this and the templates that we just reviewed at the end of our previous class on subnetting. Subnetting is a different context than the word subnet, or when we talk about subnet mask. So the subnet mask determines how big a network and how many clients it supports. The subnet mask is used in IPv4 to create a boundary in the ones and zeros that the computer can interpret to determine if and where the zip code is, right? So if you compare this to real estate and a city, the neighborhoods each have their own zip codes. And those are like subnets of the city network. And some networks are bigger than others, have more houses than others. And so you would slide the subnet mask, the ones and zeros of the subnet mask. And as you see here, you can take a large address space and break it down into multiple smaller networks with the subnet mask. When you take a traditional class network, like a class A network that can support 10 million connected clients, and then a class B network that can support 65,536 connected clients. And then you take a class C network that typically, and I'm generalizing here, there are some finer points, and those are in your study guide. Class C network with a /24 network, a /24 would support about 256 network devices. Remember that three network addresses are always required in an address range determined for a given network. One of the network addresses must be reserved, the very first one, as the identity of the network. It's called the network ID. If you add one to that network ID address, you typically have the gateway address. This is just the convention or practice in industry. And then the very last address by convention, again, is, defined as the broadcast address, where, because Ethernet and Wi-Fi are broadcast technologies, you have to have an address where ones and zeros that are sent to that address go to everyone. And this is when you're trying to find someone on the network, or you're trying to determine where does this packet go, right? The routers determine, is this local, or does it go outside, and they route traffic. This CIDR table is what's used to perform subnetting. So classless internet domain routing is when you take a given class, A, B, or C, and you decide, okay, this isn't very efficient. We're going to have to break it down into smaller networks. When you see the octets in decimal format here, the 128.0.0.0, if you look at the binary equivalent of that, this first octet is 1,000,000,000. There is a single one at the very lead, followed by 7 zeros and then 24 more zeros. Does everybody hear that?
Yeah.
Yeah.
If you take your handy dandy calculator and you turn it into a binary programming calculator, everybody can see this, right?
Yeah.
And I click on the binary and I put 1,000,000,000. You notice that the decimal equivalent of that octet is the decimal number 128. And to humanize our binary equivalents of the network address, the client address, and the subnet mask in particular, we get 128. Now, if we take this instead and we do a 11000000, now we have a decimal number that's 192, and so on. Does anyone know what the /3 is? Off the top of your head. I'm going to ask you to become so familiar with this that you can talk about some of these numbers off the top of your head. If I take 111, 0, 0, 0, 0, 0, it's 224. So in progression, 128, 192, 224, as we keep adding ones to the binary values of that byte, a byte is 8 bits, 4 ones makes the decimal number 240. 4 ones followed by 4 zeros. 248 is 5 ones followed by 3 zeros. 252 is 6 ones followed by 2 zeros. Everybody see what I'm doing here?
Yeah.
Okay. All right. So here's the progression: /13, /14, /15, 16, 17, and so on. /16 should be familiar, right? It's what they call the 2-octet boundary, right? So if you look, there's a 1-octet boundary. When you get to a /8, that's a class A network, but it's very wasteful. OMG, it is so wasteful. Okay. You can accommodate 10 million network connected clients. 10 million minus 3, because there's still a network ID, there's still a broadcast, and there's still, but I mean, who does that, right? Well, you'd be shocked. We have some organizations that have huge numbers of public IP addresses they don't need, or they could use with NAT to conserve, and they don't. They're little piglets at a trough, and they're going to relinquish their public IP addresses to the rest of the world over their cold dead fingers, right? They'll unhand those numbers with, they'll give them up with their cold dead fingers, because they realize the value of this, right? You'll notice the pattern here. As soon as you start with another 1 after this 2-octet boundary, what's the next number? 128, 192, 224, 240. Does everybody see the pattern here? Does everybody see what's going on here? It's like 128, 192, 224, 240, 248, 252, 254, 255. Then what? We start over again. 128, 192, 224. There's a pattern. You see the pattern? Know the pattern. There's only a couple of numbers you have to memorize. Only a couple of them. But once you understand how this works, there's 248, 252, 254, 255. Boom! All over again. 128, 192, 224, 240, 248, 252, 254. Boom! So everybody got what I'm talking about here?
Yeah. I see the pattern. Yeah.
This is called a pinhole. When you get to the very end of the range, when you have subnet masks that are so large in terms of ones that you get down to these last entries, it's called a pinhole subnet mask. If you have a single network device that needs network access, but you don't want anything else on that network, you use very, very large numbers of ones. And there's very little room for very many addresses, right? The tipping point is between 252 and 254. When you get to that point, you don't really have enough for a proper gateway or a proper broadcast, right? If you get to the point where it's just one address, it is a specific host mask. What am I saying? The host can be seen and the host can communicate, but there is no room for anything else. And that host doesn't have a gateway, that host doesn't have broadcast. That's a single device that's connected to a network of 1. Any questions about that? How many networks do we have if we add 1 to a /24? Does anyone recall from our previous class how many networks we have? Anyone? Oh, come on, don't be shy. What was the first spreadsheet I showed you? Can someone unmute your mic?
Is it the class A, B, C, and D networks?
Okay, so when you say class A, B, and C, those are the traditional networks that were formed a long time ago when the internet was first coming out. So 40 years ago, they were saying, okay, how do we organize the addresses that we have? But what we were doing on Wednesday is we were looking at this. So if we increase the subnet mask by just 1, how many networks can we build where we had a /24 before, and we need to break it down into smaller, more manageable networks. Smaller, more manageable networks is called network segmentation. Repite usted, por favor. Network segmentation. All right, this is the class participation part where everybody unmutes your microphone and you each say network segmentation one at a time. I'm watching.
Network segmentation.
Thank you.
Network segmentation.
There we go.
Network segmentation.
Yeah, you can say it all at once. Just unmute and say it. Let's get it all over with. But some of you were like, I'm looking at a dead mic. Zarik, network segmentation. Shande, network segmentation.
Network segmentation.
Okay, network segmentation.
Network segmentation.
Thank you. Okay, this is also called subnetting, or CIDR. Same concept. We're taking a class network and we realize it's not efficient. So we're going to add 1s to our subnet mask. In the case that we just add a single 1 and turn a /24 into a 25, we end up splitting the class C network with a /24 into 2 networks. Each have 128 instead of 256. If we subtract the 3 network addresses we require for network ID, gateway, and broadcast, look at how there's a pattern here. The network ID for the first network, when we add a 1, and we'll just use 192.168.0. Why am I using that one? Everybody with me?
Yep.
Okay. All right, I'm at a hotel. Full disclosure, the Wi-Fi here has a different subnet mask. It's not a /24. What is it? Well, I have 16 ones here. How many more do I have? Well, if it was a 128, it would be a 17. If it was a 192, it would be a 18. If it was a 224, it would be a 19. If it was a 240, it would be a 20, /20. Okay, everybody understand how I got that from those previous slides I showed you? In your home, you're going to see 192.168.0, okay? So if we have 192.168.0.0, that's the first network ID, 0.0. Or let's say you have 192.168.1. So the first network ID would be 192.168.1.0. The gateway address would be 192.168.1.1. The first usable address you could assign to any host in that network would be 192.168.1.2, .3, .4, .5, .6, all the way up to 126. That's the last usable address. 127 is the broadcast address. Now, notice the pattern here. Broadcast address, what comes next? The network ID of the following network. So that in the second network, the network ID is 192.168.1.128. Now, Why would you do this kind of thing? Here's a quick scenario. Let's pretend in your home environment you have the old folks and the young kids. Let's repeat that. I'm going to give you a colorful and creative scenario. Let's say that the adults in your home want their own network because, well, they're adults. And let's say that they want students and kids to have their own network. And they don't want the two in the same world. Why? Well, because sometimes it's good for the younger generation to have their own environment. And it's sometimes good for the adults to have their own environment. I'm just saying, this is a simple scenario. Everybody with me so far? Somebody unmute your mic, please.
Yep.
Okay.
Yeah.
So you have a Wi-Fi router that has 192.168.1.0, and it would give out 256 addresses to anybody that wants to connect to your home wireless. First of all, that's dangerous as hell. Secondly, it doesn't make any sense, right? But you could have like home connected devices, and you could have a guest connected devices, and you could create that by just modifying the subnet mask. Now you can create a totally separate network. You can have 192.168.1.0 for your home, and your guest Wi-Fi. Everybody's heard of guest Wi-Fi, right?
Yeah.
Yeah, so guest Wi-Fi would be 192.168.2.0. It's a totally different network. The only problem with that is, wow, you still have 256 addresses for the home users, and you have what? 256 addresses for your guests. Does that make sense? Would you build a hotel with 256 rooms if you knew you'd only have a dozen people in there at any time? I'm just saying, right? I'm just saying. So in this scenario, you have network 2. It starts with 128. The gateway address is one more than 128, which is 129. You can go from 130 to 254 to assign 125 possible hosts in the second network, just as you did in the first network. You can have up to 125 and 125. The last usable address for any network device, host, system, game console, smart TV, Alexa, security camera. You get the point I'm making here, right? They all have to share the same broadcast address, the same gateway address, and the same network ID if they're going to be in the same network. So the broadcast address is 255. For all of our class networking, class A, class B, class C, the broadcast address is always 255. So it's 10.255.255.255. If it's class B, it's 172.16.255.255, and so on. Remember that 255 is 8 ones in a row, okay? Any questions on the splitting it into 2 thing? Let's create 4 smaller, even more efficient networks. I'm going to increase my subnet mask from /24 to /26. I've changed my subnet mask by 2 ones. 2 squared is what? What's 2 squared? Anybody?
4.
4. I have 4 smaller networks. I have 4 smaller networks. Now bear with me. Hang tight. As I walk through this example, hopefully the pattern will start to click and the light bulb will come on and you'll go, oh my gosh, this is so simple. It's all in multiples of 2. And if I get this and I start thinking in those terms, I have had students that start to think in this way when we start getting into the Net Academy side of this, and they could easily certify networking and have a 6-figure job waiting for them as soon as they graduate. And I'm not making that up. I've seen it happen with my own eyes. So what am I giving you as you start your spring break? A gift. If you get what I'm about to share with you and it starts to click and the pattern sinks in, and your brain starts to think in this way, it means you're starting to think like the computer, and you get networking on a very basic level that most people never get, because they just know a subnet mask is some funky little number they have to keep going over and over and over again with the tech support. Have you ever called tech support and they ask you to check what's your subnet mask, what's your ID, what's your whatever? Has anybody ever done that? Anyone?
Wait,
I have.
No.
wait, say that again?
Has anyone ever called support for like gaming or for internet service and they ask you to read off stuff off your screen and they're like, what's your subnet mask? What's your IP address? Right?
What? No, because most of the time they just send it to like they normally have like a website where it has like all frequently asked questions. You don't really normally talk to anyone with video games recently. I don't know. It's kind of annoying.
Oh, wow. Well, that's changed a lot in the last 10 years.
Yeah, so like for instance, I was trying to play Red Dead Redemption 2, but for
Uh-huh.
some reason my IP address was blocked on my social club, and I haven't been able to like fix that. It
Whoa.
works like on the campus I can play, but my house it's like it doesn't let me sign in. So I guess my IP from my um house router is blocked for them for some reason.
Uh-huh. Well, there is good news. By the time we get 2 weeks into the classes after we get back from spring break, you'll know how to fix that. Hell, you'll know how to design your own network from scratch.
That'll be good.
And that's cool. That's just plain cool. Okay, so let's get back to this. We increased the subnet mask by 2 ones. 2 ones, that's like 2 squared. That's 4. That means we can make 4 networks out of a single /24. Let me repeat that. We can make 4 networks out of a /24. But the same pattern holds true if I have a /20. I just showed you that my own internet right now has a /20 subnet mask. So if I move from a /20 to a /22, I can have 4 networks, one for guests, one for the hotel staff, one for the internet service providers, and one for the guests in the hotel. And because they're in different networks, my network structure is what we call segmented, and it's much harder to hack and it's much more secure. No fancy firewalls or other nonsense required. Let that sink in a minute. The rest of the world just leaves it a /24 because they just want the darn Wi-Fi router to work so they don't get so many calls at support. My Wi-Fi router isn't working. So they set defaults that are ridiculous, that will accommodate a small herd at a family reunion with like 200 guests in every single home. OMG. Every single home is like a wide open prairie where all of the poor grazing beasts of burden are just trying to get on the internet. They're just trying to do their thing on the network, and the hackers are like, yeah, bag them and tag them, boys. This is why we're losing our shirts with network security. This is why public networks are so exposed. I'm giving you a view of a huge opportunity in terms of career. It's not just network expertise the world needs to do things more efficiently. It's also network expertise the world needs so that we don't continue to fall prey to hackers for stupid reasons. Yep, I'm excited about spring break because I am ready for it, but I want to give you an unvarnished view of 25 years of IT experience here. Right. So now we have network. We have 4 networks. Look at the pattern. Network ID is 0. So if I'm using 192.168.1 as an example, my first network has 192.168.1.0 for a network identity. The gateway is .1, 192.168.1.1. I can put my first network device on .2 all the way up to .3, 4, 5, so on, so on, so on, .62. The last one in the series for the first smaller network is a .63, and that's where everybody sends something they want everybody to see, broadcast. Put another way, if you want to let everyone in your network know a certain thing, you beam that packet to .63, and where does it go? To everybody that's connected on that network. That's what broadcast literally means. Everybody got what I'm saying there? But hey, notice the pattern. If the broadcast on the first network is 63, what's the network ID of the next one? 64. See the connection?
Yeah.
All right. Broadcast address for the second network is .127. What's the network ID for the following network? .128. Everybody see the pattern?
Yeah.
Yeah.
Okay. So the gateway address is .65. The first usable address on the second network is 66 through 126, and the broadcast is 127. Stop and tell me to slow down if I'm going too fast. The network for the third network, the ID is 128, 192.168.1.128. The gateway is .129. The first usable address is 130. The last usable address is 190. The broadcast address is 191. And there you have it. Now, here's the good news. If you go out on to your Blackboard, you will find these templates, and I expect you to use these. This is like an easy button. I want you to use these templates. They're right in here. They are right in, oh, don't make a liar out of me. We should see the templates in your references folder. I will drop all the templates in your references folder. Okay. So you will have /26, 27. You'll have, let's look at 27. Everybody see 27?
Yeah.
So I'm going from a /24 to a /27. That's 3 more ones. What's 2 to the third? 2 to the third, 2 cubed, what is it?
8.
It's 8, which means the CIDR multiple is 32. That means I have 32 addresses in each of 8 networks. The network ID is 0, the gateway is 1. I can go from 2 to 30. My broadcast is 31 in the first network. Network ID for the second network is 32. The gateway address is 33. First usable address is 34 to 62. Broadcast is 63. That's the beginning ID for the next one. If I get to the end of this, 95, that's the broadcast. The next network starts at 96. Does everybody understand? We're talking about network boundaries here. You can break the networks down into smaller ranges, and they're more manageable. And hackers can't just hop along if there's no room in the end. Hackers have a harder time when there's a lot less space on your network. Hackers can't hide if there isn't 200 different addresses they can avail themselves to at any time. Am I starting to make sense about this does it make sense? The fewer addresses you have, where's the hacker going to hide if you only have as many as you need?
Yeah.
They can't hide anywhere. You'll be looking at your Wi-Fi router going, I know I got 8 addresses. What the hell is 9, 10, and 11? What is that? An uninvited guest. It's called war driving. You find a Wi-Fi signal, you connect to it, you hack it, and now you're using somebody else's internet. It happens all the time. Don't let them. Change some settings on your Wi-Fi router. Let's look at /28. I will post each of these in the references folder so you can see them. Wait for it. There it is. Everybody see this?
Yeah.
So I go from 24 to 28. That's an increase of 4 ones in my subnet mask. What's 2 to the 4th? Anyone? 2 to the 4th is 16. That means I have even smaller networks, but I have many more of them. I have 16 separate networks, and if you're on one network and somebody else is on the other network, you can't see them and they can't see you. Does everybody get what I'm talking about?
Yeah.
You can use these templates to answer many questions about subnetting. You just open the template for the new subnet mask. If you have a /29 for a subnet mask, you open the /29. Wait for it. Wait for it. Wait for it. I thought I double clicked it. Where's my /20? Oh, there it is. Everybody see this?
Yeah.
Yeah.
So I'm increasing from a /24 to a /29. I know it's getting smaller. The mask increase is 5. What's 2 to the 5th? It's 32. I'm creating 32 networks out of the network address space where only one network existed before. It's much more efficient. It's much more defendable. Any questions? Here's the last thing we're going to cover. And I'm just going to tell you this briefly, and then we're done. There is a third innovation to help the world where we ran out of public internet addresses. And it's here. NAT was the first adaptation. CIDR is the second adaptation. The third adaptation is IP version 6. Now we're going to spend half of an entire module in this course. At the end, it's a special topic. There are 128 bits in the 6th version of IP networking. Everybody is trying to transition to this. We went from 32 bits where we had to decide how much was a network and how many hosts can we have, to an address space that accommodates so many new addresses. Each person on planet Earth can have 1 million. This is just a quick estimation. Every square meter of planet Earth can have 1 million network addresses. We should never run out in theory. We should never run out in theory, okay? I don't know of any internet service provider on island that is running pure version 6, but that's another way to get rid of the shortage of public network addresses, is to build a whole new system with 4 times the number of ones and zeros. And when you take 2 to the, let's see, 2 to the 72 power, it's like, wow, is that a huge number more of IP addresses? Now, that's all we are. Just remember, CIDR is classless. We're not using class A, class B, or class C. We're slicing and dicing like a Ginzu knife to get better utility out of our networks, right? Now, the reverse is also true. You can decrease the subnet mask and then double the number of hosts, quadruple the number of hosts, increased by a factor of 8 the number of hosts. That's called supernetting. Supernetting. We aren't talking about that today. Instead, we're going to close our session early. Does anyone have, or can anyone think of any questions, interesting questions or interesting comments to offer at this time based on the material presented? Okay, fly, be free. Enjoy your spring break safely. We'll see you on the other side. Please be sure you reconcile. If you have any unfinished, unsubmitted stuff, now's the time to get it in. I'm posting credit for everyone. And if it ain't there, there's no credit. Just saying, okay?